Good morning, children. Stay safely at home. Now I am starting the last topic of this chapter, that is the examples and real world application of thermal expansion of solid, liquid and gas. One by one I'll just explain all the applications and examples. First, the thermal expansion of solid. Alright, that we apply in our day-to-day life. First example is riveting. Now the question is, what is a rivet? Rivet is nothing but a small piece of steel rod which is used to join two metal rods together. Alright, now that is known as rivet, means a small steel rod which is used to join two metal rods together is known as rivet. Okay. How riveting is done, that you understand. First of all, two metals are taken and a hole is drilled within it. Clear? And then what is done, that rivet is made red hot. Means it is heated up until and unless it becomes red hot and it becomes soft. Then that softened rivet or that softened red hot steel rod is inserted within that hole drilled within the metal plate. Alright. And then by a hammer it is hammered so that it just get inside the hole, as well as the upper end it get flattened over the metal rod. So what is happening after that, when you allow it to cool down, then what will happen, the steel rod won't be able to regain its original shape and size. Rather, when it will cool down, it will contract and it will join the two metals together tightly with one another. Alright. So, in case of riveting, we are using the concept of thermal expansion of solid. Okay. The next one is breaking of thick glass tumbler. You will see that if you take a thick glass tumbler, thick means what? You see the wall of the tumbler, it is thick like this. It is having one inner surface, one outer surface. Now, you know, glass is a bad conductor of it. So, suddenly when you are pouring a hot liquid into it, then what will happen? The inner surface, it will expand because it has got the heat suddenly, but the outer surface it will not be able to expand. Why? Because glass is a bad conductor of heat, so it will not transmit the heat quickly. So what is happening? The inner surface suddenly it is increasing, the volume is increasing, and the outer surface trying to remain in its own volume. So due to that a stress develops, and due to which the tumbler breaks or crack develop. Now, how to overcome it? You just keep here within this a metallic spoon. The metallic spoon, what it will do, when the hot liquid will pour on it, the metallic spoon, as it is a good conductor of it, it will absorb the heat from the liquid. So, the inner surface will not receive a large amount of heat suddenly, and it will prevent the breaking of the tumbler. Okay. Then next example, laying of rail tracks. You will see, you will observe that when the rail tracks are laid, then always a gap is kept between the two tracks. Okay. Why the gap is kept? Because you know, if a gap is not kept, then during summer it is a metal rod. No, during summer what will happen? Suppose the gap is not there, track is continuous. Then during summer what will happen? It will expand, but there is no place to expand. So what will happen? It will just raise up. Means it will move in the upward direction. It will bend. Clear? And during winter what will happen? It will contract, and due to contract stress may develop and it may break also. So, to prevent it, what is done? While laying the rail tracks, a gap is kept. So, due to the gap, what is happening? Just understand it. During summer, when it will expand, then you see the length of the gap will decrease, but there will be no damage to the rail track. And during winter what will happen? When it will contract, then you see the gap of the rail track, it will increase, but it will not again produce any kind of damage in the railway track. Clear? So this is the reason why a gap is kept between the two rail tracks while laying it. Then next one, mounting of bridges. So if you consider mounting of bridges, then you will see that suppose this is the bridge. Alright. Then you will see one end of the bridge, it is tightly packed with the concrete pillar. Alright. But the other end, what is done? Other end, it is not tightly packed with the pillar, rather a gap is kept, and here 2-3 wheels, okay, are kept below the bridge. Apply your common sense, easily you can give. Why? Just it allows, means this space is given so that during summer, because the bridges are made up of iron beams. So during summer when it will expand, then what will happen? It will get the space to expand. So it will not cause any damage to the bridge. And during winter also, it will be allowed to contract easily without producing any damage to the bridge. Alright. The next one is when telephone and electric cables are laid. Then what happens, you know that the electric and telephone cable, they are laid on two pillars. No, not means continuously they are hanging on in air. What happens? The pillars are there at certain gaps and the cables are connected with the pillars. Okay. Now what is done? If the line is laid during summer, just you first try to understand it. Suppose there are two pillars here and you have just laid the cable like this tightly. Then what will happen, you see? During summer it will expand, alright, and during winter it will contract. So during winter when it will contract, then what will happen? That tension will develop within it. If the tension is very much high, then what will happen? It may cause damage to the cable. That's why if the cable is laid in winter, then it is tightly connected, because in winter it is already contracted. Then during summer, what will happen? When it will expand, then it will just sag little bit. Is that clear? Now, if the electric line or the telephone line is laid during summer, then during summer, how it is? During summer, it is never just put it straight. Why? Because if you just put it like this during summer, then during winter what will happen? It will try to contract, then it will cause a damage. So during summer when it is laid, then it is laid this in this way. Means the cable is means it will sag between the two poles. Means it is loosely laid when it is laid during summer, but when it is laid during winter, it is tightly laid. Clear? So that is what is the reason? That during summer it can expand and during winter it can contract easily without causing any damage to the cable line. The next one is, if you consider the glass utensils that we use in kitchen, you will see that the glass, what kind of glass we use? We use Pyrex. What kind of glass we use? This is a very important question. What kind of glass we use? That we use Pyrex glass. Alright. Why Pyrex glass? Because for Pyrex glass, coefficient of cubical expansion is very small. It means that when the temperature increases, temperature changes, then volume of Pyrex glass does not change by a large amount. So what is happening? That when this kind of glass utensils you are using in microwave or any kind of heating oven, then what is happening? Due to expansion, it will not break, it will not be damaged. Why it will not be damaged? Why it will not break? Because as I said already, due to change in temperature, increase in temperature, amount of expansion is very small, and that's why Pyrex glass is used. So how you can get question on the last application, that which kind of glass is used for the glass utensils we use in kitchen? What kind of glass we use? Pyrex. Why Pyrex? Because for Pyrex, this is the first point you have to write. For Pyrex, coefficient of cubical expansion is very small. As a result, due to increase in temperature, amount of expansion of Pyrex glass is less. Alright. Now here the examples, practical examples, real life examples, applications that I discussed here one by one. Verbally I said I have not written anything. Alright. So now it is your duty to note it down properly just by listening to the lecture. Alright. Because I have observed that what you people are doing, that you are not listening to the lecture, blindly you are copying down what is written on the whiteboard. That's why purposely this time I have not written anything. Okay, I have explained but not written anything. So it is your duty that from the explanation you must write down the way I have explained. Means whatever verbally I have said, you just note it down in the study material copy. Alright. Then next one is expansion, practical expansion. Then next I am discussing the practical application and examples of thermal expansion of liquid. Now first is liquid thermometers. You know that liquid thermometers may be the mercury thermometer or alcohol thermometer. Now what is there in the thermometer? Mercury is there. It is in the form of the liquid. Now when you want to measure the fever or you want to find out the temperature of any object, then what you do? You keep the thermometer in touch with the hot object, isn't it? So you see what is happening. The thermometer bulb as well as the liquid within it absorbing heat from the body, from the hot body, and they expand. And when they expand, then their expansion, depending on their expansion, a scale is calibrated and we can read out what is the temperature of the hot body. Alright. So you see, in case of liquid thermometers, when we are using liquid thermometer, we are applying the concept of thermal expansion of liquid. Then the next example is radiators of automobiles. You know that in every automobile there is an engine, and when the engine runs for a long time or runs continuously, then what happens? Engines becomes very hot, and when it becomes hot, then it may cause damage or some problem or difficulties may arise. So always we need a radiator which will radiate the heat, heat produced within the engine, and it will cool down the engine. So generally in case of in radiator, what we use water. So when a radiator is filled up with water, then water never filled up. Just you consider, suppose this is the radiator, then water never filled up till the top level. Alright, a space is left. Why? Because when the water, engine will become hot, radiator will become hot, water will evaporate, and when water will evaporate, then it will cool down the engine. That is the way. And when water will evaporate, then it will absorb the heat from the engine. But another thing will happen. You see, when the water will receive the heat, then it will expand. So the space is left so that water can expand and it will not come out from the radiator and cannot cause damage to the engine. That's why water is never filled up till the full beam of the up to the topmost level of the radiator. So always certain space is left. The next one is same medicine bottle. In medicine bottle, always medicine is never filled up till the never it is completely filled up. Medicine never filled up the bottle completely. A certain amount of space is left above the medicine when it is liquid form. Why? Because when you are transferring the medicine from one region to other, then if you are transferring the medicine from cold to hot region, then what will happen? Medicine is in the liquid form, so it will expand. So if the no space is there within the bottle, if you fill the bottle completely with the medicine, then what will happen? It may cause damage to the bottle and a medicine may come out. So that's why always certain amount of space is left above the medicine bottle. It never completely, medicine bottles are never completely filled up by the medicine. Then the next one is thermal expansion of gases. Now the first example of thermal expansion of gas is automobile tires. You know that the tires generally we filled up by air. Alright, so during summer, when air is filled within the tire, then less amount of air is filled within the tire. Why? Because during summer the surrounding temperature is high, so if you fill a large amount of air within it, then what will happen? The air, when due to the high temperature of the surrounding, due to large temperature of the surrounding, the air within the tire, it will expand. So amount of air more means what will happen? It will create a large amount of pressure on the tire, and it may happen the tire may burst. So to avoid it, what is done during summer, when the tires are filled up by air, then less amount of tire is filled up by less amount of air. Then next one is gas thermometer. Just like liquid thermometers, it based on the expansion of thermal expansion of liquid. Like that, gas thermometers, they are working also based on the thermal expansion of gases. Means when heat is given to the gas will expand. Then next one is explosive. Explosives are made on this fact that when a gas is heated strongly and suddenly, then if the amount of expansion is suddenly very large, then it may cause explosion. So that is the basic working principle of explosive. Means in explosive, gases are filled in such a manner, a large amount of gas is there, and suddenly when it is heated up, suddenly it expands so much that it causes a big explosion. Alright, so these are all practical examples, real life applications of the thermal expansion of solids, liquids and gas. So this is the end of this chapter. Kindly learn all the topics discussed in this chapter thoroughly. Thank you, girls.